Hi, my name is Josh Bruno. This presentation is in reference to the 8th chapter of The Essentials of Modern Statistics with Microsoft Excel by Anderson, Sweeney, and Williams. This chapter is in reference to the interval estimates, and in this chapter, Anderson, Sweeney, and Williams noted the purpose of an interval estimate is to provide information about how close the point estimate which is provided by the sample, is to the value of the population parameter. The general equation for a population mean interval estimate can be seen here, where x hat is the mean of the sample. It's going to be plus or minus your margin of error. Now, which equation you're going to use to calculate your population mean interval estimate is going to depend on whether you know your standard deviation of the population. If you do happen to know the standard deviation of the population, you use the following equation. X hat again is the mean of the sample, and it's going to be plus or minus your z-score value, which you calculate using alpha here, your level of significance, and then sigma here is going to be your population standard deviation divided by the square root of your sample size n. And looking back on alpha 2, alpha, your level of significance, is equal to 1 minus your confidence level. The most commonly used confidence levels are going to be 90%, 95%, 99%. So respectively, the most common values for alpha are going to be 0.1, 0.05, and 0.01. Now, using Excel, if you do know your population standard deviation, you use the following input to calculate your margin of error, which, by the way, also would be equal to this equation right here. Just get rid of that. So yeah, you type in equals confidence period norm, and then in the parentheses put your alpha, level of significance, comma, sigma, which is going to be your population standard deviation, and n, your sample size. Now, if you do not know R, which is more common, you can use this equation. You're now using your t-score instead of your z-score, still calculated with alpha, your level of significance. And now you're also using your standard deviation of the sample rather than the population to approximate the population standard deviation. Again, divided by the square root of n, your sample size. Now, sometimes people or companies or what have you like to know the sample size that would be needed to hit a certain confidence level or level of significance, along with a specific margin of error, in which case they use the following equation, where the variables are all the same except E here, that's going to be your margin of error, and also your Z value here can be switched out to t-score, and also that would also have to be switched out with right here, your sigma value would be switched out with the mean standard deviation as well, sample standard deviation, if you do not know the value of the standard deviation of the population. Now, also, you can use interval estimates for population proportions, which you would use generally this equation here, your population, your sample proportion plus or minus the margin of error, and in the following equation, to use it, your sample proportion times n, your sample size, has to be greater than 5, as well as n, your sample size, times 1 minus your sample proportion. And you would use the following equation, where p hat here again is going to be your sample proportion, and alpha again your level of significance, and it's going to be divided by n here, your sample size. And also the following equation can be used again to find your necessary sample size for a population proportion, where E again is going to be your margin of error And that is it. Thank you for listening.